As you settle comfortably into your bed tonight, feeling the familiar weight of your blankets and the solid support of your mattress beneath you, take a moment to remember where you are in the grand scheme of things. You're lying in a room, in a building, on a planet that's spinning through space at 1,000 miles per hour, orbiting a star at 67,000 miles per hour, in a galaxy that's racing through the cosmos at over 1 million miles per hour. Yet here you are, perfectly still and peaceful, about to drift off to sleep while participating in this cosmic dance. Tonight, we're going to take a gentle journey outward from your quiet bedroom, through the layers of space, seeking an answer to one of the most profound questions humans have ever asked. Where does space end? The answer, as we'll discover together, is far more beautiful and mysterious than you might imagine. Let's begin this peaceful expedition by slowly expanding our view outward from where you rest. Feel yourself becoming weightless, rising gently above your bed like a feather caught in a warm updraft. As you float through the ceiling of your room, notice how the familiar objects of your daily life, your furniture, your books, the photographs on your walls, begin to shrink below you. These intimate details of your personal world become part of a larger pattern as you drift up through the roof of your home. Below you now, the lights of your neighborhood create a warm constellation of human presence. Each glowing window represents a life, a story, a small universe of dreams and experiences. The streetlights form gentle rivers of illumination, connecting home to home in a web of community that stretches as far as you can see. If you live in a city, observe how the lights cluster more densely toward the center, creating a brilliant galaxy of human civilization. If your home rests in the countryside, notice how the scattered lights form islands of warmth in the peaceful darkness, each one a beacon of life and consciousness in the vast night. As we continue our serene ascent, your city or town spreads out like a glowing web below us. The streets form delicate patterns of light against the darkness, major highways becoming bright arteries pulsing with the movement of late-night travelers, while smaller roads create intricate networks that speak of human organization and purpose. From this height, you can see the wisdom in urban planning, how neighborhoods cluster around schools and parks, how commercial districts serve as bright nodes in the network of community life. The arbitrary boundaries that seem so important on the ground, property lines, city limits, even national borders, reveal themselves as invisible constructs, existing only in our minds while the earth itself flows seamlessly from one landscape to another. Mountains don't recognize political boundaries. Rivers flow where gravity takes them. Forests grow where conditions allow, creating their own borders of green that shift with the seasons and the centuries. Higher still, and the curve of Earth begins to reveal itself. That gentle arc that speaks of our planet's perfect spherical form. This is a sight that only a few hundred humans have ever witnessed directly, yet it transforms everyone who sees it. The thin, luminous line of our atmosphere becomes visible, that delicate shell of air that cradles all life on Earth. It's no thicker than the skin of an apple, this precious boundary between our living world and the infinite cosmos beyond. As you rise through this gossamer-thin atmosphere, notice how it changes layer by layer. The troposphere, where all our weather occurs, extends only about 7 miles high. So thin that if Earth were the size of a basketball, our entire life-sustaining atmosphere would be no thicker than a coat of paint. Here, clouds form intricate patterns that shift and flow like the thoughts of a dreaming planet. Great spiral storms rotate slowly over the oceans, while delicate cirrus clouds streak across the sky like brushstrokes on a cosmic canvas. Above this lies the stratosphere, home to the ozone layer that protects us from harmful solar radiation. This invisible shield has been Earth's guardian for millions of years, allowing complex life to venture out of the protective depths of the oceans and colonize the land. Higher still, we pass through the mesosphere, where meteors burn up in brilliant streaks. And finally, the thermosphere, where the aurora dance in curtains of green and gold, painting the upper atmosphere with the interaction between Earth's magnetic field and the solar wind. As we drift beyond Earth's atmosphere, we enter what astronauts call the profound silence of space. Here, there is no air to carry sound, no wind to disturb the perfect stillness. It's a silence so complete, it becomes almost musical in its purity. Not the absence of sound, but the presence of infinite peace. This is the silence that has existed between worlds for billions of years. A quietude so deep, it seems to hold all the universe's secrets in its gentle embrace. Space, we discover, is not the empty void we might imagine. Even in the apparent emptiness between Earth and Moon, there exists a complex environment of invisible forces and fields. The solar wind, charged particles streaming out from the sun at hundreds of miles per second, creates a dynamic medium through which we're now traveling. Earth's magnetic field extends far into space, creating a protective bubble called the magnetosphere that deflects most of these solar particles, channeling them around our planet like water flowing around a stone in a stream. Earth hangs below us now, like a blue marble, suspended in black velvet, its swirling white clouds creating ever-changing patterns across the deep blue of oceans and the warm browns and greens of continents. From this perspective, our planet reveals its true nature as a cosmic oasis, a water world unique in our solar system, perhaps unique in our galaxy, possibly unique in the entire universe. The blues are so vivid, they seem to glow with their own light, while the continents drift beneath their blanket of atmosphere, like ancient lands seen through crystal clear water. The Pacific Ocean spreads across nearly half the planet, its deep blue surface broken by chains of islands that mark the locations of ancient volcanic activity. The Atlantic Ocean, younger in geological terms, continues to grow wider by a few inches each year as the seafloor spreads along the mid-ocean ridge. The land masses tell their own story of deep time, the distinctive outline of Africa fitting like a puzzle piece against South America, evidence of the ancient supercontinent Pangaea that broke apart millions of years ago. Watch as the Terminator line, that soft boundary between day and night, slowly creeps across Earth's surface. This line represents the eternal rhythm of our planet's rotation, the gentle cycle that has marked time for over 4 billion years. On the day side, sunlight illuminates everything with golden clarity, revealing the intricate details of mountain ranges, river systems, and the geometric patterns of agricultural land. On the night side, the lights of human civilization twinkle like scattered stars, marking our species' recent but remarkable emergence as a force of consciousness and creativity in the cosmos. The night side of Earth tells its own fascinating story. The bright clusters of light mark our great cities, New York, London, Tokyo, burning like beacons of human activity. The darker regions aren't empty, but represent forests, deserts, and wilderness areas where life continues in different forms. You can trace the course of the Nile River by the string of lights along its banks, or follow the Trans-Siberian Railway as it stretches across the vastness of Russia like a glowing thread connecting east and west. From this height, you can see the International Space Station as it orbits Earth every 90 minutes, a bright star moving steadily across the night sky. Inside that small outpost of humanity, astronauts from different nations work together, conducting experiments that benefit all of Earth's inhabitants, while experiencing the profound perspective that comes from seeing our planet as a unified whole, without borders, floating in the cosmic dark. Our moon, that faithful companion, glides serenely in its eternal dance around Earth. At 250,000 miles away, a distance that light covers in just over a second, it seems close enough to touch. Yet, it represents a journey that would take our fastest spacecraft 3 days to complete. This distance, which we can express as about 30 Earth diameters, was first accurately measured by ancient Greek astronomers using nothing more than careful observation and geometric reasoning. The moon's surface, unmarked by weather or erosion for billions of years, preserves a record of the early solar system's violent history. Every crater tells the story of ancient impacts, when chunks of rock and ice left over from the planet's formation rained down on the inner solar system in what astronomers call the late heavy bombardment. The largest impact basins, visible as dark patches from Earth, were created by asteroid-sized objects that struck the moon with unimaginable force, melting the lunar crust and creating the Maria, the seas that early astronomers thought were bodies of water. The moon's gentle gravitational pull creates the rhythm of our tides, a cosmic heartbeat that has pulsed steadily for billions of years. This gravitational dance between Earth and Moon has profound effects that extend far beyond the simple rising and falling of ocean water. The Moon's pull stabilizes Earth's axial tilt, giving us regular seasons instead of chaotic climate swings. It gradually slows Earth's rotation, making our days longer over geological time. When the Moon first formed, Earth's day was only about 5 hours long, and it may have been crucial in the development of life itself, creating tidal pools where the first complex chemistry of life could have emerged from the interaction of land, sea, and sky. As we watch, the Terminator line slowly creeps across the Moon's ancient, cratered surface, creating a landscape of stark beauty where the interplay of light and shadow reveals every detail of the lunar terrain. The lunar highlands, bright and heavily cratered, represent the Moon's original crust, while the darker Maria show where ancient lava flows filled in the largest impact basins. Brilliant rays of material blasted out by relatively recent impacts extend like cosmic spider webs across hundreds of miles of the lunar surface. The space between Earth and Moon, though it appears empty, is crossed by invisible lines of gravitational force that bind the two worlds together in their cosmic waltz. This region is increasingly populated by human artifacts, satellites in various orbits providing communication, navigation, and weather monitoring services that have become essential to modern life. The International Space Station traces its path through this realm, carrying its crew of cosmic explorers who conduct experiments impossible to perform under the constant pull of gravity. This Earth-Moon system exists in a delicate gravitational balance with the Sun, locked in an orbital dance that has remained stable for billions of years. This stability has been crucial for the development of life. Our distance from the Sun places us in what astronomers call the Goldilocks zone, where temperatures are just right for liquid water to exist on Earth's surface. Too close, and we would be a hellish hothouse like Venus. Too far, and we would be a frozen wasteland like Mars. As we prepare to venture deeper into our solar system, we can still see Earth clearly. Our blue haven of life suspended in the cosmic dark, the place where you lie safely in your bed, ready to dream of the infinite wonders that stretch endlessly beyond our small, perfect world. The Earth-Moon system, beautiful in its simplicity and profound in its implications for life, represents just the first step outward in our cosmic journey, a gentle introduction to the vast scales of space and time that await our exploration. Solar System Journey. Our solar system and the realm of planets. As we drift farther from Earth's comforting blue glow, we enter the broader realm of our solar system, a family of worlds united in their elegant dance around our life-giving sun. The distances here begin to stretch our earthbound imagination in ways that require entirely new scales of thinking. If Earth were the size of a marble, the Moon would be a small bead about 7 marbles away. But our Sun, that golden sphere of nuclear fire, would be a beach ball, nearly half a mile distant. And even that represents just the inner edge of our solar system's true extent. The Sun itself is a marvel of cosmic engineering that defies easy comprehension. Picture a perfect sphere so large that Earth could fit inside it over 1 million times, yet so precisely balanced in its nuclear fusion that it has maintained nearly constant energy output for over 4.5 billion years. The Sun contains 99.86% of all the mass in our solar system. If you gathered together all the planets, moons, asteroids and comets, they would represent barely a rounding error compared to our star's immense bulk. At the Sun's core, temperatures reach 27 million degrees Fahrenheit, conditions so extreme that hydrogen atoms are stripped of their electrons and fused together to create helium in a process so efficient that it converts 4 million tons of matter into pure energy every single second. This is the same process that powers hydrogen bombs, yet the Sun performs it with such gentle precision that it has provided steady, life-giving warmth to Earth for eons and will continue to do so for another 5 billion years. The energy created in the Sun's core begins its journey as high-energy gamma rays, but the Sun is so dense with plasma that those photons take an average of 100,000 years to random walk their way to the surface, bouncing between charged particles in a cosmic pinball game of unimaginable complexity. The photons of sunlight that warmed your face today began their journey in the sun's core during the last ice age on Earth, when our ancestors were just learning to use tools and create art in caves. The sun's visible surface, called the photosphere, roils with convection cells the size of entire countries, creating a constantly changing granular pattern that makes our star's surface look like a golden ocean of plasma in perpetual motion. From this surface, streamers of charged particles flow outward at speeds of hundreds of miles per second, creating the solar wind, an invisible atmosphere that fills our entire solar system and extends far beyond the orbit of the outermost planets. Embedded in this solar wind are loops and streams of magnetic field lines that originate deep within the sun's interior. These magnetic fields occasionally snap and reconnect in violent events called solar flares, releasing as much energy as billions of nuclear weapons in a matter of minutes. When these disturbances reach Earth, they create the beautiful aurora that dance around our polar regions, painting the night sky in curtains of green, red and gold as charged particles interact with our planet's protective magnetic field. As we glide outward from the sun's warm embrace, we encounter the inner planets in their stately orbits, each world a complete universe of landscapes and weather patterns, shaped by its unique distance from our star and the particular circumstances of its formation. Mercury, racing around the sun in just 88 Earth days, presents one of the most extreme environments in the solar system. This small world, barely larger than Earth's moon, experiences temperature swings of over 1200 degrees Fahrenheit between its sun-baked day side and its frozen night side. Mercury's heavily cratered surface tells the story of the early solar system's violent bombardment period, when leftover debris from planetary formation created a cosmic shooting gallery that scarred every solid surface in the inner system. The planet's large iron core suggests that a massive impact early in its history may have stripped away much of its original rocky mantle, leaving behind a world that is essentially a giant metal ball wrapped in a thin shell of rock. Venus, shrouded in brilliant clouds of concentrated sulfuric acid, presents perhaps the most hellish environment of any planet in our solar system. Despite being twice as far from the Sun as Mercury, Venus is actually hotter at its surface, reaching temperatures of 900 degrees Fahrenheit, due to a runaway greenhouse effect that demonstrates the delicate balance required for a world to remain habitable. The planet's dense atmosphere creates a pressure at the surface equivalent to being nearly a mile underwater on Earth, while acid rain falls from the sky before evaporating in the intense heat long before reaching the ground. Venus rotates so slowly that a day on Venus, 243 Earth days, is actually longer than its year of 225 Earth days. Even stranger, it rotates backwards compared to most other planets, likely the result of a massive impact that literally knocked the planet upside down in its distant past. Despite these harsh conditions, Venus may once have had oceans and a more temperate climate, offering a sobering reminder of how planetary environments can change dramatically over geological time. Mars beckons from its orbit with landscapes that seem almost familiar, yet utterly alien. The red planet's rusty color comes from iron oxide, rust, covering much of its surface, the result of billions of years of oxidation in its thin atmosphere. This world of ancient river valleys and vast canyon systems tells the story of a planet that once had a thicker atmosphere and flowing water on its surface, conditions that might have allowed life to emerge in its early history. Mars hosts geological features that dwarf anything on Earth. Olympus Mons rises 13 miles high, nearly 3 times the height of Mount Everest, and is so large that its base would cover the entire state of Arizona. The planet's canyon system, Valles Marineris, stretches over 2,500 miles long and up to 4 miles deep, making the Grand Canyon look like a small scratch by comparison. These massive features formed over billions of years on a world where plate tectonics never developed as they did on Earth, allowing individual volcanoes and rift valleys to grow to enormous sizes. The thin Martian atmosphere creates weather patterns unlike anything on Earth. Dust storms can envelope the entire planet for months at a time, while the low atmospheric pressure means that liquid water cannot exist on most of the surface. It would instantly boil away, regardless of temperature. Yet, signs of ancient water flow are everywhere. Dried riverbeds, what appear to be ancient shorelines, and minerals that form only in the presence of liquid water. Between Mars and Jupiter lies the asteroid belt, a region that captures our imagination as a chaotic jumble of rocky debris, though the reality is far more serene. Despite containing millions of objects, the asteroid belt is mostly empty space. You could fly through it randomly and have virtually no chance of hitting anything. The largest object, Ceres, is now classified as a dwarf planet and contains about 1/3 of the belt's total mass. This small world, just 600 miles in diameter, may harbor a subsurface ocean beneath its icy crust, making it another potential harbor for life in our solar system. Each asteroid in the belt tells the story of our solar system's formation 4.6 billion years ago. These objects are remnants of the primordial disk of dust and gas from which the planets formed, cosmic time capsules that preserve samples of the original material from which our entire solar neighborhood emerged. Some asteroids are metallic, likely the cores of small planets that never fully formed. Others are rocky or icy, representing different regions of the early solar system where various materials could condense from the cooling nebula. Beyond the asteroids, we encounter the realm of the gas giants, worlds so different from the rocky inner planets that they seem like visitors from another universe entirely. Jupiter dominates this outer realm, like a king among planets, so massive that it contains more matter than all the other planets combined. This giant world serves as a gravitational anchor for the entire outer solar system, and its immense pull has acted as a cosmic vacuum cleaner throughout solar system history, protecting the inner planets from the comets and asteroids that might otherwise have prevented life from developing on Earth. Jupiter's great red spot, a storm larger than our entire planet, has raged continuously for at least 400 years and possibly much longer. This colossal hurricane rotates counterclockwise with winds reaching 400 miles per hour, powered by heat rising from Jupiter's interior and sustained by the planet's rapid rotation. Jupiter's day lasts only 10 hours, despite its enormous size. The storm's red color comes from complex organic compounds created by the interaction of sunlight with chemicals in Jupiter's atmosphere, painting this cosmic tempest in shades of rust and salmon. Jupiter reigns over its own miniature solar system of at least 95 known moons, 4 of which rival or exceed the size of terrestrial planets. Io, the innermost of these large moons, experiences such extreme gravitational flexing from Jupiter's immense pull that its interior remains molten, creating the most volcanically active world in the solar system. Sulfur compounds ejected by these volcanoes paint Io's surface in brilliant yellows, oranges, and reds, while some volcanic plumes reach heights of 200 miles above the surface. Europa, slightly smaller than Earth's moon, hides beneath its icy surface an ocean that may contain more liquid water than all of Earth's oceans combined. The gravitational dance between Jupiter and its other large moons generates enough heat through tidal flexing to keep this ocean liquid, creating conditions that might harbor life in the eternal darkness beneath Europa's frozen shell. Dark streaks across Europa's surface suggest that this buried ocean occasionally breaks through the ice, creating temporary connections between the hidden sea and the vacuum of space above.
Ganymede, the largest moon in our solar system, is bigger than Mercury and possesses its own magnetic field, the only moon known to have one. This magnetic field may protect a subsurface ocean of its own, while also creating aurora that dance around Ganymede's poles, visible to telescopes as ultraviolet emissions in the thin atmosphere surrounding this ice-covered world. Saturn follows Jupiter in majesty, adorned with the most spectacular ring system in the solar system. These rings, composed of billions of ice particles, ranging from tiny grains to house-sized boulders, create one of the most beautiful sights visible through a telescope. The rings are incredibly thin, less than half a mile thick in most places, despite spanning nearly 200,000 miles in diameter. If you could build a scale model where the rings were as thick as a sheet of paper, they would stretch for nearly half a mile across. The rings are not solid structures, but rather collections of individual particles, each following its own orbit around Saturn, in accordance with the precise laws of orbital mechanics. The intricate structure within the rings, gaps, braids, spokes, and shepherd moons, creates patterns of such delicate complexity that they seem almost like cosmic clockwork, demonstrating the mathematical beauty underlying all celestial motion. Saturn's moon system rivals Jupiter's in diversity and wonder. Titan, larger than Mercury, harbors lakes and rivers of liquid methane under a thick, orange atmosphere denser than Earth's. This moon experiences methane weather, clouds, rain, and seasonal changes involving hydrocarbons instead of water. Enceladus, much smaller but equally fascinating, geysers water ice and organic compounds from its south polar region, indicating a subsurface ocean that might harbor the chemical conditions necessary for life. As our journey takes us toward the outer edge of the planetary realm, we encounter worlds that challenge our understanding of what planets can be. Uranus, tilted on its side like a rolling ball, experiences the most extreme seasons imaginable. Each pole experiences 42 years of continuous daylight, followed by 42 years of unbroken darkness. This strange orientation may result from a collision with another planet-sized object early in the solar system's history, an event so catastrophic that it knocked an entire world onto its side. Neptune, the windiest world in our solar system, hosts storms with winds reaching 1,200 miles per hour, despite being so far from the sun that it receives only 1,000th the sunlight that Earth does. The energy driving these incredible winds must come from the planet's interior.
but the mechanism remains one of the many mysteries of our outer solar system. Neptune's largest moon, Triton, orbits backwards and shows signs of geological activity, despite the incredible cold at that distance from the Sun, suggesting it may be a captured object from the outer reaches of the solar system. At the edge of the planetary realm lies Pluto and its companions in the Kuiper Belt, a region of icy worlds that preserve samples of the original materials from which the outer planets formed. Though no longer classified as a planet, Pluto remains a fascinating world with a complex relationship with its largest moon, Charon. The two worlds are so close in size that they orbit around a point in space between them, creating a true double-planet system, locked in gravitational embrace. Beyond even these distant worlds stretches the Oort cloud, a vast spherical shell of icy objects that extends nearly halfway to the nearest star. This is the source of the long-period comets that occasionally grace our skies, pristine remnants of the solar system's formation that spend most of their existence in the profound cold and darkness at the very edge of the Sun's gravitational influence. From our vantage point at the edge of the solar system, we can look back toward the Sun and see our entire cosmic neighborhood spread out in the gentle order of planetary orbits. Earth appears as a tiny point of light, lost in the Sun's glare from this distance, yet it remains the center of our concern and affection, the small blue world where you rest safely in your bed, dreaming of the vast cosmic architecture that surrounds and enfolds our small corner of the universe.
The Milky Way galaxy, journey into interstellar space and our galactic home. As we drift beyond the influence of our Sun and into the vast spaces between stars, we enter a realm of profound serenity that stretches our understanding of emptiness and distance to entirely new scales. The interstellar medium, that near-perfect vacuum, dotted with perhaps one hydrogen atom per cubic centimeter, creates a silence and stillness so complete that it transforms our very concept of what space means. Here, in the gentle darkness between worlds, we can begin to perceive the true architecture of our cosmic home, the magnificent spiral galaxy we call the Milky Way. The transition from interstellar to interstellar space is gradual and subtle. The solar wind that has accompanied us throughout our journey slowly weakens until it can no longer push against the thin interstellar medium, creating a boundary called the heliopause, where our solar system truly ends and interstellar space begins. The Voyager spacecraft, humanity's most distant ambassadors, have crossed this boundary and entered the realm between stars, sending back data from a region no human-made object had ever explored. Our nearest stellar neighbors begin to reveal themselves as we journey outward, each one a sun in its own right, with its own story of formation, evolution, and perhaps planetary companions. Proxima Centauri, the closest star to our Sun, lies over 4 light-years away, a distance so vast that if our solar system were the size of a quarter, Proxima Centauri would be another quarter nearly 2 miles distant. This is the fundamental scale of interstellar space. Even our nearest neighbors are separated by distances that light itself takes years to cross. Alpha Centauri,
A triple star system containing Proxima Centauri dominates the night sky of the southern hemisphere and has captured human imagination for millennia. The two sun-like stars in this system orbit each other every 80 years, while tiny Proxima Centauri, a red dwarf barely 1/8 the mass of our Sun, orbits the pair at a distance comparable to Neptune's orbit around our Sun. Recent discoveries have confirmed that Proxima Centauri hosts at least one planet in its habitable zone, making it the closest known world where liquid water might exist on the surface. As we continue our peaceful voyage deeper into interstellar space, more stellar neighbors emerge from the cosmic distance like lights appearing through fog. Sirius, the brightest star in Earth's night sky, reveals itself as a binary system where a brilliant blue-white star dances with a tiny white dwarf companion, the collapsed remnant of a star that exhausted its nuclear fuel millions of years ago. The contrast between these two objects illustrates the diverse endpoints of stellar evolution. While the primary star continues to shine with the intensity of 25 suns, its companion represents the fate that awaits stars like our own Sun in the distant future. Vega, that brilliant beacon in the constellation Lyra, served as the northern pole star 12,000 years ago, and will do so again in about 13,727 years, as Earth's axis slowly wobbles through its 26,000-year precession cycle. This star, slightly more massive than our Sun, is surrounded by a disk of debris that may be in the process of forming planets, offering us a glimpse of what our own solar system might have looked like during its youth. Each star we encounter tells a unique story of cosmic evolution. Some are young blue giants, burning bright and fast like celestial fireworks, consuming their nuclear fuel so rapidly that they will live for only millions of years before exploding as supernovae. Others are ancient red dwarfs, glowing softly with the patience of cosmic time, so efficient in their nuclear burning that they will continue to shine steadily for trillions of years, longer than the current age of the universe by a factor of hundreds. The space between these stars is not truly empty, but filled with the interstellar medium, a thin soup of hydrogen and helium gas, left over from the Big Bang, enriched over billions of years with heavier elements forged in the cores of dying stars. This material creates vast clouds and nebulae that serve as stellar nurseries where new generations of stars are born. The Eagle Nebula, the Orion Nebula, the Horsehead Nebula. These are not merely beautiful objects in the night sky, but active star formation regions where gravity slowly condenses the interstellar medium into new suns and planetary systems. Some of these stellar nurseries span hundreds of light years and contain enough material to form thousands of stars. Within them, we can observe the entire process of stellar birth. Dark globules where gravity has begun to concentrate matter. Protostars still shrouded in the dusty cocoons of their birth, and newly formed stars whose intense radiation gradually clears away the surrounding material to reveal planetary disks where worlds may be forming. As we expand our view to encompass thousands of stars, the grand spiral structure of the Milky Way begins to reveal itself, like a cosmic flower slowly opening its petals. We live within one of the galaxy's spiral arms, the Orion Arm or Local Arm, a graceful curve of stars, gas and dust that sweeps through space like a frozen wave in a cosmic ocean. These spiral arms aren't solid structures, but rather density waves, regions where stars and gas cluster more thickly due to gravitational effects, creating the beautiful pinwheel pattern we can observe in other galaxies. The spiral structure of our galaxy creates a rhythm of star formation that has persisted for billions of years. As gas clouds encounter the density waves of the spiral arms, they become compressed and begin to collapse under their own gravity, triggering bursts of star formation that illuminate the arms with the brilliant light of young, hot stars. These massive stars live fast and die young, exploding as supernovae that compress nearby gas clouds and trigger the formation of new stars in an ongoing cycle of stellar birth, death, and rebirth. From our position roughly 26,000 light-years from the galactic center, about halfway out from the center to the edge, we can sense the majestic rotation of our entire galaxy. Like a cosmic ballet performed on an unimaginably vast stage, the Milky Way spins slowly and gracefully, completing one full rotation every 225 to 250 million years. This galactic year is so long that Earth has completed this cosmic journey only about 20 times, since complex life first emerged in our ancient oceans. The rotation of the galaxy follows a complex pattern that differs markedly from the rotation of a solid object. Stars closer to the center orbit faster than those on the outer edges, but not as much faster as they would if the galaxy were held together only by the gravity of visible matter. This discovery led astronomers to propose the existence of dark matter, invisible material that outweighs all the visible stars and gas in the galaxy by a factor of roughly 5 to 1. At the heart of our galaxy lies something both mysterious and magnificent: Sagittarius A star, a supermassive black hole containing the mass of 4 million suns, compressed into a region smaller than Mercury's orbit. This cosmic giant doesn't devour the galaxy, but rather serves as its gravitational anchor, around which hundreds of billions of stars orbit in perfect gravitational harmony. The region around the galactic center glows with the light of densely packed stars and the warm radiation from cosmic dust heated by their combined energy. Recent observations have revealed stars orbiting incredibly close to this central black hole, some completing their elliptical orbits in as little as 16 years, despite traveling at speeds reaching nearly 20% the speed of light at their closest approach. These observations provide dramatic confirmation of Einstein's theories of relativity, showing how extreme gravity warps space and time in the vicinity of the black hole. The Milky Way stretches approximately 100,000 light-years from edge to edge, containing somewhere between 200 and 400 billion stars. If each star were a grain of sand, our galaxy would contain enough sand to fill several Olympic swimming pools. Yet despite this incredible abundance of worlds, the galaxy is mostly empty space. Vast, peaceful distances between islands of matter and energy that allow light to travel freely across cosmic distances. The disk of our galaxy, where most of the stars reside, is remarkably thin compared to its width, only about 1,000 light-years thick at the center and even thinner at the edges. If we could shrink the Milky Way to the size of a dinner plate, it would be thinner than a sheet of paper, yet it would contain all those hundreds of billions of stars arranged in elegant spiral patterns. Above and below the galactic disk lies the galactic halo, a roughly spherical region populated by ancient globular clusters, each containing hundreds of thousands of stars bound together in dense spherical communities. These clusters are among the oldest objects in our galaxy, cosmic time capsules that preserve the chemistry and structure of the early universe, when the first generation of stars was forming from primordial hydrogen and helium. The globular clusters follow highly elliptical orbits that carry them far above and below the galactic plane, like cosmic fireflies dancing around the galaxy's center. Some of these clusters contain stars that are nearly as old as the universe itself, ancient suns that began shining when the cosmos was only a few billion years old, witnesses to almost the entire history of cosmic evolution. As we journey toward the edge of our galaxy, the stellar density gradually decreases, and the majestic spiral structure slowly fades into the more random distribution of stars in the outer halo. Here, we encounter some of the most ancient stars in the galaxy, poor in heavy elements because they formed before generations of stellar death and rebirth had enriched the interstellar medium with the products of nuclear fusion. At the very edge of the Milky Way, we encounter the mysterious dark matter halo, invisible matter that outweighs all the visible stars and gas by a factor of 5 to 1. We cannot see this dark matter directly, but we can sense its gravitational influence through the way it shapes the galaxy's rotation and holds the entire structure together like an invisible scaffolding extending far beyond the visible disk. The dark matter halo may extend as much as 200,000 light-years from the galactic center, twice the diameter of the visible galaxy, creating a vast sphere of gravitational influence within which satellite galaxies, like the large and small Magellanic Clouds, orbit our galaxy like cosmic moons. These smaller galaxies, visible to the naked eye from the southern hemisphere, contain billions of stars of their own and are slowly being torn apart by the Milky Way's gravity, creating streams of stars that will eventually be incorporated into our galaxy's outer regions. And then, at the boundary of our galaxy, we face the next magnificent scale of cosmic structure. Beyond the Milky Way's edge lies intergalactic space, a realm of such vast emptiness that even our galaxy, with its hundreds of billions of stars, becomes just one island of light in an ocean of darkness that stretches for millions of light years in every direction. Yet even in this apparent emptiness, we are not alone. The Milky Way belongs to a small cluster of galaxies called the Local Group, bound together by gravity in a cosmic dance that spans millions of light years and billions of years. Our nearest major neighbor, the Andromeda Galaxy, shines across the 2.5 million light years that separate us, appearing to the naked eye as a faint smudge of light that contains twice as many stars as our own galaxy. From our position at the edge of the Milky Way, we can sense the vast scales that await us in the next phase of our journey. The Local Group itself is just one small cluster among millions of others, organized into an intricate cosmic web that structures the entire observable universe. Superclusters of galaxies stretch across hundreds of millions of light years, connected by filaments of dark matter and ordinary matter that create the largest structures known to exist. But for now, as we prepare to venture into the realm beyond galaxies, we can still feel the gentle gravitational embrace of our home galaxy, that magnificent spiral of stars where our solar system continues its ancient orbit, where Earth spins peacefully through space, where you rest safely in your bed, dreaming of the infinite architecture that surrounds our small corner of the cosmos. The Milky Way, vast beyond human comprehension, yet intimate in its role as our cosmic home, represents just one step in our journey toward understanding where space might end. We have traveled from your bedroom to the edge of our galaxy, expanding our perspective by factors of millions and billions. Yet we have barely begun to explore the true scales of the universe. Ahead lies the realm of galaxies upon galaxies, structures so large that our entire Milky Way becomes merely a point of light, and mysteries so profound that they challenge our very understanding of what it means for space to have boundaries at all. As we drift at the edge of our galactic home, surrounded by the ancient silence between stars, we can take comfort in the knowledge that we carry with us the perspective of Earth, that small blue world where consciousness first emerged to contemplate the cosmos, where life learned to look up at the stars and wonder about its place in the infinite dance of matter and energy that fills the universe with light and beauty beyond all imagination.